So this is part 2 of this particular problem. So here we go. There's different part A, B, C, D, E, and F now. So follow along. Same diagram, objects being projected 30 meters per second upward from the top of a building that is 80 meters tall. Okay, so here's point A, B, C, D. All right, so let's knock it out. Let's do part A, B, C on this particular slide. Part A asks you to find what is the ball's instantaneous speed, aka the magnitude of your instantaneous velocity at 4.2 seconds. If you watched the first video, we know that it took about 3.06 seconds to get to point B. Therefore, 4.2 second would imply that it's on its way down. Okay, so we should get a value that makes sense. All right, let's do part A. Part A, to find the instantaneous speed or instantaneous velocity at any given point in time. The function is final velocity is equal to g times t plus vi. Here we know our acceleration due to gravity, which is negative 9.8 meters per second square. Our time here is 4.2 seconds because I've chosen to start at 0 second and go all the way to 4.2 seconds as asked here in part A. But if I start at 0 second, my initial velocity is a positive 30 meters per second because it is being projected upward. So if I simplify my math, negative 9.8 times 4.2 gives me negative 41.16. I want to add the 30 to that. This will leave me a value of negative 11.16, which makes sense. It's on its way down and it's starting to pick up speed in the negative direction. So the answer to this one makes sense to me. All right, so but it asks for average speed, so we just need to box the magnitude. So my answer would simply be 11.16 without the negative sign. So here I've made a note for you, no direction. So it's important that you, as you practice, understand what variable is being asked of you. It's just instantaneous speed, which imply it is a scalar. So find the velocity, but present your answer with just the magnitude. So again, the answer is just 11.16 meters per second. All right. Let's do part B. Part B asks us to find the ball's average speed from point A to C. So it starts at point A, it rose to point B, and then from point B, it came down to point C. Based on the diagram, point A and point C are at the same vertical position. So I know that to do average speed, I need to find the total distance. Okay, so average speed is distance over time. Well, I know that I can find the total distance going upward. Once I know the distance going from A to B, the distance from B to C should be the same due to symmetry. So I'm going to find the length of this arrow, aka the distance going upward, which you found in the previous video, but I'll do it again here really quick. To find the vertical displacement from A to B, apply the displacement function, which is vit plus 1/2 gt squared, vi being 30. And here, you notice I highlight time. I don't know what time is. I don't know how much time it took to go from A to B, but I can find that really quickly by using the average acceleration equation and flipping around delta t and g. So to find t, we do vf minus vi divided by g. But here vf is 0 because at point B, it rose to the highest point it can go. So vf is going to be 0. Well, vi is 30 and it's a negative because here the sign in front of vi is negative, so I carry that over. So 30 divided by 9.8 is simply 3.06, which we found in the previous video. So I'm just going to label it here real quick. So change in time here to go from A to B is 3.06 seconds. Well, part B wants us to go from A to C. Okay, so again, you can find the distance from A to B and then just double it up because from B to C is the same distance. So if I use this time and I plug it into my t's here that are unknown in my displacement function, it looks like this. 30, t is 3.06, 1/2 negative 9.8, 3.06 squared. If you simplify that in your calculator, you should get the same value as we did in the previous video, which is 45.9 meters. Well, it wants from A to C, so therefore I know that it took a distance of 45.9 meters for the ball to come to a stop. Therefore, it's going to fall back the same distance. So to find average speed, I would just double up my distance, or I can just add the same value. So 45.9 plus another 45.9. So on the way up, on the way down, time on the way up, time on the way down. So therefore, if you add up 45.9 with another 45.9, you get 91.8. And then the time here would just be 3.06 plus another 3.06, which is 6.12. Simplifying the calculator, you get 15 meters per second. Because it asks for average speed, there is no need for direction. This is a scalar quantity, so I made a note there. There's no direction here. So as you practice, understand what's a vector, what is a scalar, know when to include direction, know when not to, and watch out for the word magnitude. Part C, I'm not going to do any work here, okay? So part C here asks for the average velocity from point A to C. If you kept up pretty much this semester for kinematics, point A and point C are at the same position. So by definition, average velocity is change in position over time, or aka your displacement. But it started at point A, it rose up to point B, it came to point C, but point C and A are really the same position. So why it traveled a certain amount of distance, it has not moved, aka displaced itself relative to its position. Okay, so therefore delta y here is just 0. 0 divided by time is just 0. So the answer for average velocity here is just 0 meters per second, because by definition it is defined as displacement over time, and our displacement here is 0 because it came back to where it started. All right, let's move on to part D and E. Part E asks you to find where is the ball relative to the floor after 7.5 seconds. So in order to know where it is relative to the floor, okay, we have to find how far the object has gone. Okay, so here I've decided to start with my displacement function. Why? Because I need to find out my delta y after 7.5 seconds. So I know the ball is going to go up and it's going to come down, but where is it relative to its starting point? All right, my VI is going to be 30. Time here, I want to plug in 7.5 seconds. G is negative 9.8. Time is 7.5 seconds squared. And then if you simplify that on your calculator, you get 91.8 plus a negative 45.88. Simplify this, you get negative 50.625 meters. Now, this is not your answer. Okay, this is not your answer. What I just found is how far has the ball traveled or displaced after 7.5 seconds. So watch the right side of the screen. What I just found is that after 7.5 seconds, the ball has traveled downward from where it started, a displacement of 50.625. I drew the arrow pointing down because the answer we got was negative 50.625. Well, negative would imply that it's now below where it started. How far below? 50.625. But the distance that it fell is just 50.625 because distance is a scalar. But this is not our answer. The question is saying where is the ball relative to the floor? So again, watch the right side of my screen where the cursor comes up. This is what it's looking for, this arrow that I'm flickering back and forth, right? Because that arrow measures from the floor up to where the ball is now. Well, to find this missing leg, it's pretty easy. We know the height of the building is 80. We know it fell a distance of 50.625 after 7.5 seconds. So to find this particular height above the floor, we literally just do basic math. 80 minus 50.625. All right, so without complicating it, to find the height above the floor, we take the 80. 80 meters above the floor, aka the height of the building where it started. Subtract for how far it has fallen, which is 50.625. Therefore, our answer here is 29.375. So after 7.5 seconds, if you were to look up relative to the floor, the ball is at a height of 29.375 meters. And that's our answer, okay? So it's important to understand what it is that's being asked and then find it properly. All right, let's do part E. Part E asks you to find the velocity just before it strikes the floor. This is one of those moments where you cannot put 0 meters per second because it's looking for just before it strikes the floor, which would imply that it is moving. Okay, so for these types of parts, do not put 0. Some kids or some students, they'll just think, oh, it hits the floor, so it stops. No, it's looking for the instantaneous just before it hits the floor, which implies that it's still moving. So you need to make sure you don't make false assumption here. All right, I think the easiest way to do this one without knowing time is using this kinematics equation that is time independent, because I'm looking for VF. I know VI, I know G, I know delta Y, so I'm just going to manipulate this algebraically real quick. To get VF squared by itself, I'm going to add VI squared to both sides. Therefore, VF squared is equal to 2G delta Y plus VI squared. I know my G, I know my delta Y, I know my VI, so I'm just going to plug and chuck here. G is negative 9.8 meters per second square. Delta Y, this is very important that you plug this stuff in correctly. Delta Y here must be negative because it started at point A and it's looking for the velocity at point D, which is below point A. So it has fallen 80 meters, or like negative 79.99999 meters if you want to be all technical. Okay, but I'm just going to use negative 80 here. And then we're going to add the 30, we're going to square that. Okay, so it's important that you understand delta Y is negative for this one because the ball is beneath its starting point. All right, simplify this on a calculator. You should get 1,568 plus another 900 because 30 squares 900. We sum that up, we get 2,468, but then this is VF squared. So to find VF, we radical both sides. The square root of 2468 will give us a positive or negative 49.7. So this is one of those times you got to make sure you pick the right answer because it has to make sense. It asks you for the object's velocity just before it strikes the ground. Using common sense, it's on its way down. So therefore, I'm not going to go with the positive value. I'm going with the negative value because it's traveling downward. So my final answer is going to be negative 49.7 meters per second. Okay, so I'm going to go with the negative because it's what it's doing. The motion is downward at point D. All right. However, there is a different way to do part E if you watch the first video and utilize the information that I found there. So I'm going to show you how to do this quickly, assuming you want to maximize on your learning here. All right, to find the final velocity, I can go back to my final velocity function, which is just acceleration times time plus VI. Well, I know my G is negative 9.8. Okay, so this is where it gets a little tricky if you haven't seen the first video. Time I know is 8.13 seconds because in the first video I found the total time that it takes for it to hit the ground from the starting point. And VI here is 30. So I took a screenshot of my work here if you didn't watch the first video. Using your displacement function, you can find how much time it took to hit the ground. So I did all this, and once I got to here, I plugged it into a quadratic solver on the internet and I got a time of 8.13. So this is where the 8.13 seconds that I highlighted in yellow comes from. So if you don't understand the work in this box, you might want to go back and watch the first video. But if you do understand it, then let's use it. Okay. So again, G is given to us negative 9.8. The total time that it takes to hit the ground is 8.13. My VI here is 30 because I'm using the total time, which is from 0 second all the way to the floor. And if we simplify this, we get negative 79.674 meters per second plus 30. And then as you can see, the answer is negative 49.7, which is the same as what we got there. Okay, so there are different strategies. Just as long as your interval and your reference point is consistent, you should always get the same answer. All right, let's move on to F. Okay, part F asks you to find the ratio of the change in velocity. Notice here is change in velocity, not final velocity, not initial, not average. It wants the change in velocity between 1 to 2.2 seconds. Compare it to the change in velocity between 3 to 5.4 seconds. This one's pretty straightforward. Okay, I've done this for another video, so if you need to watch the other ones. Here, I just carry the same statement down where the blank is, and then I'm just going to solve for delta V. Acceleration is change in velocity over change in time. I've chosen to go with this function because G is constant and then delta T is given in these statements. Okay, I'm going to isolate for delta T by multiplying both sides. I'm going to isolate for delta V by multiplying both sides by delta T. So really, I'm just going to move this delta T up to the left side in the numerator. So it's gravity times time that gives me my change in velocity. And I'm going to apply this function twice. I know on the left side of the function, my 1 to 2.2 second is a difference of not 1.1, excuse me. Let me exit this. It's 1.2 seconds. My apologies there for not doing basic math. Okay, as I was saying, the time interval here from 1 to 2.2 is 1.2 seconds because 2.2 minus 1 is 1.2. The time interval on the right side of the statement is from 3 to 5.4, which is the difference of 2.4. 5.4 minus 3 is 2.4. And I'm just going to use those two times in my statement. So where G is, I carried it down. Wherever delta T is on the left side of the statement, it's 1.2 seconds. Okay, and I'm going to do the same thing. I'm going to use this function twice. G, I carry it down. Except for my change in time here on the right side of the equal sign is 2.4 seconds. And that's delta V. Well, it's delta V. You have two functions for delta V. So you want to set these two functions equal to each other. Okay, so therefore, that's what I want to do. I want to set g times 1.2 second, which is here, equals to g 2.4 seconds. And let's just carry the blank down. Okay, the blank has to be carried down. And then the blank is where my heart is. And you notice here, if you are paying attention, the g will cancel on both sides because it appears on both sides. Here I've chosen to just use heart. Again, you can do whatever symbols you want. And then g cancels out. And then here we have heart is equal to, 1.2 equals to 2.4. So therefore, to solve for heart, you would just divide both sides by 1.2 seconds. And then you get the statement. Okay. So really, you're just solving for a blank, or just some unknown variable. All right. So therefore, you have 2.4 seconds divided by 1.2 seconds. You notice here the units will cancel out. So therefore, 2.4 divided by 1.2 is just 2. And I've made a note here that the coefficient 2 has no unit. So it's important that you understand when you're doing the accepted ratio problem, your final statement has no unit because the units are already canceled. All right. I hope that helps. Stay nerdy. Don't be whack.